So what mode should we be on? Degrees. So go to the mode, which is next to our second button. And I'm going to hover over to, hover down and over to degree. Because at the moment, we know only degrees. And then go to your home screen. Put your head up. Okay, let's write our acronym on the very top. We have SO. What was the other one? Ka and Toa. And it stands for sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. So let's look at example number 1, A only. And let's put in what I know. Blake, let's read. Find
the measure of the angle opposite to the 8-inch leg.
So I need to figure out, we have, the legs are given to be 8 and 15. And I want to find the angle that's opposite of 8. Is it angle A or angle B? Angle A. So let's hover over to A. So depending on which acute angle you're looking at it from, your opposite and adjacent may change, right? So in this case, here's our hypotenuse. From the angle when I jump, that is considered opposite, and the remaining must be the adjacent. So what was the order of naming these that I told you guys last time? Always HOA. It just helps. Okay, so then let's kind of figure out which trig function must I use. If I know 15 is adjacent, 18 is opposite, which one has opposite and adjacent on the ratio? Tangent. So let's write on here, tangent of an angle. The angle, we do not know what that is. I'm just going to call it A. Is equal to, what number is on the opposite? What number? 8. What number is on the adjacent? 15. So my variable is A. What do y'all remember about getting rid of this trig?
Negative.
We did that negative inverse, right? The negative 1 power. So we have tangent inverse. And what that does is it gets rid of the norm and the inverse out. So now we know angle A is equal to something. And notice it says nearest the whole number. So let's go to our calculator. Tangent inverse is second tangent of 8 over 15. And let's anticipate something. Angle A has to be greater than angle B or less than angle B. If 8 is less than 15, then whatever's on the opposite of 8 must be less than, meaning it should be less than 45 degrees. Do we all see that? Let's see if that is true. Is 28 degrees less than 45? Definitely. So always look at the relevance of the number, so then that way you can kind of self-check. And it says to the whole numbers, I don't need any decimals. Is everyone good with it? So when you're looking for an angle, you'll always use the inverse. Always, always. What's that?
Mine's not getting.
Because your mode was probably on radian mode.
No, mine's on degree.
It was? Let's double check. Did you put in tangent inverse?
Yeah.
Did you put in 8 on top and 15 on the bottom?
Oh,
You swapped.
no, I took 5.
5. Oh, instead of 15. All right, let's go on to the back page. And I want you to write SOHCAHTOA on the top again. So here's our SO, there's our KA, and TOA. So this one says to find all missing measures, the angles and lengths. Could we use Pythagorean theorem to find this side right here? And it says to round, so I'm going to do everything on the calculator. Are we okay with that? Okay, so I have my a squared plus b squared. That's going to be 8 squared plus 10 squared. That is our c squared value, but I want the c alone, so what must I do to that number? Square root it. So that's going to give me some decimal, and it says I want all the side measures to the hundreds and all the angles to the whole. So this will be 12 point how many? 81. So we have many, many options on this one. I can start by finding angle A, or I could start by finding angle C. Which one should we pick? What do you want? A or C? A, all right? And let's label everything from angle A. Here's our hypotenuse. When I jump from angle A is our opposite. And then there's our adjacent. Will it be clever for me to use this rounded value to find the angles? Will it be accurate? Not as accurate. I will use these two. So are we using sine, cosine, or tangent? Tangent again. So we have tangent of the angle A is equal to what over what? 10 over 8. How do I get rid of our tangent? Inverse. And the inverse and the norm goes away. And again, we're looking for an angle, so we have to use the inverse. Second tangent of 10 over 8. Let's anticipate something. 10 is greater than 8, so opposite of 10 better be greater than 45 degrees. Correct?
Yeah.
Is that true? Yep. So here's our 51 degrees. Then the other by a triangle sum theorem must be 39. So did I find all the sides and angles then? Boom, done. Let's look at part B on example number 4. And actually we're doing part B and C together. But I'm gonna put in all in one number on part B. I want you to give me a right triangle. And then give me a similar, bigger right triangle. These are similar, like I said. And I want to talk about our special, or triangle, what was the word? The Pythagorean triple. Y'all remember 5, 12, 13 was a Pythagorean triple? Let's do a recall. 3, 4, 5 is what? A triple. And we have 5, 12, and 13. What's the other most often used one that starts with 7? 7, 24, 25. Do you have to memorize this? If you don't have it memorized, can you use Pythagorean? You can, but it's good for like ACT and SAT purposes because it goes really fast. Here's something interesting about these numbers. What is 3 squared?
9.
What is 4 plus 5?
9.
Interesting. What is 5 squared?
25.
What is 12 plus 13?
25.
Weird. What is 7 squared?
49.
And 24 plus 25?
49.
Fun fact. All right. So our main focus on this one was 5, 12, 13. So let's write 5, 12, and 13. Let's say because they're similar, I choose to double the sides. That's going to give us 10 and what? 24, 26. As long as the two triangles are similar, the angles that are corresponding, should it double or should it be the same? Should be the same. This angle right here must be the same with this corresponding, and this angle down here must be the same as this corresponding. And that's a right angle, by the way. Okay, that's all we need to know. When two triangles are similar, corresponding angles must be the same. Okay? All right, let's go on to example number 5. Get your earbud out, please. Okay, on number 5, Jack, let's read.
15-meter pole is leaning against the wall. Base of the pole is 2 meters from the wall. Right angle of the pole makes 3 different.
So the hardest thing about the word problem is how do we draw the image and what goes where? So we know we're looking at a right triangle unit, right? So here's our right triangle. And something is leaning. When something is leaning, is that my leg or the hypotenuse? Hypotenuse, so I'm going to say here's my pole. That is 15 meters. And then it's saying it's going against the wall. And then we also have something called the ground. So let's see what our final answer is going to be. It says, find the angle that the pole makes with the ground. So I'm going to highlight the pole, highlight the ground, and that's going to make this x, the angle, as our unknown. Is there any other information that I did not label? The ground is 10. So let's label. We have our hypotenuse here. The angle that it jumps from is our opposite, and then the remaining must be the adjacent. Let's write out SOHCAHTOA on the top. So what I know is my hypotenuse and adjacent. Which one has a combination of H and A? Cosine. So we have cosine of an angle, which is our unknown x, is equal to, what number is the adjacent? 10 over 15. How do I make x by itself? Inverse. So we have cosine inverse on both sides. These two are going to cancel. So I should get an acute angle, that's for sure. So we have second cosine of 10 over 15. What if I did this? I'm gonna change this. What if I did cosine inverse of 2 over 3? Is 2 over 3 equivalent to 10 over 15? We'll get the exact same answer. Boom. And this one is an angle. Let's make all the angles to a whole number. 40 how many? 48 degrees. Putting that degree sign is like putting a unit on. So are we comfortable with finding an angle? You inverse it at all times. So we have our one last problem. Number 7A. Jack, let's read. 7 and A.
So following with our calculator, pick the sin A equals 0.5 and then find the angle.
Is this sin or sine? Should be sine.
Oh, sine.
It looks like sin because it's abbreviated. We're going to use a calculator. Why not? All right. Let's rewrite this off to the side. We have sine of angle A is equal to 0.5. Grant, are you going to write with me? Like now? Okay. My A is almost by itself. What do I do on both sides? Uh-oh. What do we do it? Inverse it. These two are going to go away. So angle A, we have sine inverse of 0.5. Boom, 30 degrees. I'm going to actually mention something that you do not have to write. Are we ready? When you get to pre-cal, you're going to be anticipated or asked to find 30 degrees without a calculator, and I'm going to share how to, all right? You do not have to write this down. Let's put in 30, 60, 90, if you're writing with me. 1 root 3 and 2. Isn't sine basically opposite over hypotenuse? Yeah? Isn't 0.5 technically 1 over 2? Do you see that's my opposite? Hypotenuse? And then we have that 30 degrees? Pretty interesting. Just think about it.